Hi friends, today again there is topic of DWDM. DWDM basically multiplexing technology. Just like FDM is frequency division multiplexing, TDM is time division multiplexing, and TDM is used in HDH actually basically. So DWDM is wavelength division multiplexing. DWDM and HDH produce optical signals. Here PCM produces electrical signals, but DWDM and HDH produce optical signals. DWDM uses fiber optic. It reduces media cost because the multiple channels are riding on a single optical fiber, so it is reducing the media cost. ADH can carry max 40G channels. There is main reason, and that is dispersion. Dispersion is the main reason which is limiting the HDH max capacity. Second reason is a problem of optical detection circuitry process. So HDH bandwidth limiting factors are dispersion and optical detector technology. Dispersion is of two types: chromatic dispersion and polarization mode dispersion. Current dates we are data hungry, so we need to go for DWDM for more and more data. DWDM works on refraction concept. What is the refraction concept? Light is basically comprised of seven different colors, as we know. Prism breaks a white light. Prism breaks a white light to different colors. When light enters from light media to dense media, it diffracts from its optical path, and this is refraction. Each and every wavelength of light is of slightly different speeds. So prism breaks white light into different colors because each and every wavelength of light is of different speed. And this is basic theme of DWDM technique. DWDM technique assigns every signal a different frequency. In 1980s, there was wideband WDM, and that was two channel system only. In early 90s, there was 2 to 8 channel system. It was calling passive WDM. Now we are using DWDM. There is more than 100 channels. DWDM is cost effective. It is multi-protocol supportive. Yeah. Here, DWDM accepts multi-protocol signals at its client, so it is supporting multi many protocols, and it is scalable. It is reliable. Dispersion is the broadening of light pulse. It is very critical factor. Dispersion is very critical factor. Excessive broadening causes bits to overflow. Excessive broadening of light signal causes the bits to overflow over their time slots. So in this way, dispersion is limiting that bandwidth. Polarization mode dispersion disturbs signals which is more than 10G. If we are using more than 10G bandwidth, then polarization mode dispersion is disturbing the signal. DWDM is compatible with all transmission because it accepts all transmission signals at its client, so it is compatible. It works on long distance. Yeah, it is supportive for long distance communication also. Just we need to add more and more optical transmitters. In CWDM, we are not able to amplify signals. CWDM main drawback is we are not able to amplify signal here. SDH is TDM based technology, and DWDM is WDM based technology, as you know, and it is supporting more than 100 channels. Currently, 128 and 160 channels are in operational in DWDM. DWDM enables bidirectional transmission. It enables bidirectional transmission. CWDM main drawback is channel spacing. Its channel spacing is 20 nanometers. This is very high. In WDM, it is going to limited to 4.8 nanometer only. And in DWDM, we uh, work on C and L bands only, and it requires more, but it requires more power than CWDM. In DWDM, our main uh, advantage is here we can use EDFA because for amplifying the light signal. EDFA is basically the fiber amplifier or light amplifier, we can tell it. And fiber amplifiers are 50% cheaper than regenerators. If we do not use fiber amplifiers, we have to use regenerator, and so in this way regenerator sides are costlier, and if you use fiber amplifiers it is 50% cheaper, and there is no need of optoelectronic conversion. HDS signals are STM1, STM4, STM16, STM64. Here we use overheads like path overhead, section overhead, and there is in HDS there is center clock for synchronization purpose. In HDS we need a center clock for synchronization purpose. Thank you friends.